Hello and welcome to another one of my Python tutorials where today I'll be going over subroutines but applying that to doing a set of different functions in trigonometry. But before I do that, please remember to hit that like button on this video, subscribe to my channel and share this far and wide. Without further ado, I'm going to go into subroutines. So what task is it today? We need to write a big Python program that will allow users to pick a different function in trigonometry. So these are the subroutines we need. So we need degrees and radians all the way to the hypotenuse. So we need to have a menu below to allow the user to pick one of the options stated above. So what I mean by above is these options. So there's 15 of these. 15 is a lot, so we're going to make things a little bit easier for ourselves by doing a main and saying, right, these are the trigonometric functions which we need. So these are all the functions. These are all the subroutines we need. What do we need to do first? Well, before we do that, we're going to need to import math and import CMath. Because they're the modules you'll need to access mathematical functions. First things first, we need degrees and radians. So that's a subroutine we need. Bingo. So we're asking the user to put in pi, and we're asking for the radian number. So to do that, we need to do print math degrees. It might be easier just to show it like this. So math degrees, brackets, and then another bracket for math.pi for pi divided by pi num. Okay? And then what we will then need is print math degrees not degrees, we need radians. And I'm going to do radian number. So that will help us work it. And that is the essence of the first subroutine. But I want to test it. But we can't exactly do that. So what we're going to do is we're going to do 1, 2, 3, the double quotes. And I'm going to cut those. And I'm going to paste those all the way here. So now we can just go in and test. Degrees and radians, we're going to enter 23, 2, and there's our degrees. There's our degrees, and there's our radians. Okay? So, however, when doing subroutines on anything, it will be worth us doing sys, time, and os. Reason being is because we want to make our functions a bit cleaner. So what we can do is we can do time sleep, so it's going to delay the execution of a program, and then we're going to do os system clear. So what that will do, so when we click on that now, we're going to press 1, we're going to delay, and it's cleared, and it's gone straight to the enter a number. So I'm going to apply that to all of them, which we can do as we go on. And then if we really want to, we will do an else. And I'm going to put the else here because what I'm going to do here is a sys exit, so that will just end the module. So that's the idea behind this code there, okay? Okay, what's the next one? We need to do sine. So we ask them to print out the sine. So, nice easy subroutine, def call sine, ask us to input a pi number, and then you call the sine function. You use the math module for pi, and then you get divided by the pi number. And we can take that quote out there. So let's run that. 2. So we're going to enter 2, then we got our 1. Okay, so that's sine. Next one we could do tan and cos together because these are very small subroutines. So we're figuring out the tan of a number and the cosine of a number, or the cos of a number. So we don't need to worry about that one now. And then what we can do is just time and sleep. And then we can do the same right here. So those are the basics so far. The next one we need to do is the arcsine, arccosine, and arctangent. So we would need to do def a sine, colons on the end. We're going to ask a user to enter a number, as we normally do. Boom, we got it. Then we're going to do print a sine. So we do print math a sine number. So in that case, it will be a 1. And then we enter 2 numbers, and then we try and get the complex. Then we try and get the complex. And then once we've got that, then we print out the arcsine. So what we've got, we are going to test this one out. We're going to test the 3 of these out together. Or we'll actually test this one out. And let's not forget to add these. So I'm going to run that. So I'm going to enter a 5. I'm going to enter 12. Can't do that. Why can't we do that? For arcsine, because we've got an error there. So there's a value error there. Even though I've done the int. So, what I should have done. So 1. So always enter a 1. Enter a number. Say I want to do 2. Say I want to do 2.3, 3.2. We've got the arcsine there. So, what we could do in this instance is we could do a while loop. So while number is not equal to 1, we can extend this subroutine to make the user type in a 1 rather than have the program end. So let's try that again. So I can enter 2. Nope, 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 nope. Fine. So now we go. So we got 12, 12.3. Use a complex function, and that figures out the and use a cmath asyn function. We got the arcsine. Okay. And it will be the same for acos and atan, but the difference is you're going to be using the functions just the same way. But what we can do is we can do a while loop now in the other two, and we can make sure the user actually types in. We can make sure now user types in that number, and we can make sure they type in that number. So while it's not equal to 1, and while that's not equal to 0. So what that's going to do is, so we've added in some while loops. A cos, A tan, and we can add these nice functions in here. So time, sleep, 1, OS system, clear. Let's do these, run. Right, let's try number 6. 2, 0. Yep, we're going to have 0 now. Let's say us to do 12.3, 1.4. We've got the arc cosine. Run. Number 7, arc tangent. 2, nope, 1. We got the 1. Let's say we do 35.5, and let's say we do 35 points. Let's say we do 12.4. So that will work out the arc tangent. So it still uses the CMath function, and we're still using a complex function, and we're using all of the same stuff that we've used before when we worked out the A sine, the arc sine. So the arc cosine and the arc tangent, they're basically the same, but the only difference is we're using A cos and we're using A tan. They're the only differences there. Okay, so what have we got next? We got sin, so sin. That's the hyperbolic sine of an angle. So let's see how we do that one. I'm going to do that in a moment. So we've got a hyperbolic sine of an angle. We're asking the user to input those two numbers, and then it's going to use a complex function to put x and y together, and then it's going to use a cmath.sine function to actually work out the hyperbolic sine. So number 8. So we want to enter a number being a 1, and we want to enter a 1. Hyperbolic sine right there. However, let's say I want to do 2.1 and 2.4. Got the hyperbolic sine worked out same way but different numbers. So we've used the float numbers to put in our numbers. The complex puts x and y together, and thereby we're using a z variable, which is the final answer based on the cmath.sine. Okay? And it will be the same for when you do hyperbolic cosine of the angle and hyperbolic tangent. We're doing a hyperbolic tangent of an angle. So the workings is going to be exactly the same. The only difference is you've got the cosh instead, and you've got the tan h instead. They're the only differences there. Okay? So let's put in these two babies. And there we have it. So now we want the A sine. A cosh and A tan. And the A tan too. And then we will do the hypotenuse. So first, we're going to do this. because we don't need those just yet. So let's have a look, shall we? We've got inverse hyperbolic sine, inverse of a hyperbolic cosine, and the inverse of a hyperbolic tangent. Okay, so we can't do anything there because there's bugger all there. So we'll just have to do that. Just comment out, because that was invalid. So we got the inverses now. 11. Let's say I want to enter 1.0. I'm going to enter 2.0. So it's going to go, so we'll use a z variable like before, using a complex function to put x and y together, and then we're going to use the ASINH function within the CMath module. And what that's going to do is going to give us the inverse hyperbolic sine. And if we were to try, say, number 12, it's going to be exactly the same way as before, but the only difference is we've got the ATAN. We've got the ATAN. Yeah, we've got the ATAN. A sine, A cosh. I'm going to have the ATAN, which is a hyperbolic tangent there. And then ATAN 2. Right, let's try number 13. For the hyperbolic tangent. So that's fine, works exactly the same way. You just got A tan and H. That's literally the only difference there. But we can also have the angle between the positive x-axis and the coordinates of x, y. So in this one, let's say I was to enter two numbers, and then all we don't need the complex function anymore, but we will need the A tan 2. And that will combine the x and y. So that's the angle between, because it's adding the two together, and it's given us that spot. That spot of coordinates there. Okay? So that is those subroutines done. What we should have added here was these modules, was these functions, just to make our program neater when we actually get it to work. And now we can bring in the hypotenuse. So hypotenuse, it's a word you will find when you do Pythagoras' theorem in maths. So adding the different sides of the triangles times in the square numbers, basically. So you would do def hypotenuse. Let's make sure that's spelled exactly right, because if it's not, then we're going to be in trouble when we actually do it. So just do a nice print statement, and then you would do x equals float input, tell the user, enter a number. Tell the user, enter a number, and you can copy that to make the y. You can copy that in, make the y, ask them to enter another number. And then what you will do now is you'll print the hypotenuse, and you will now use the math.hypot function. So that will give us the hypotenuse. So if we're to run it, so enter a number. Let's say I want to enter 1.0 and 1.0. Hypotenuse is going to be 1.4. So what we've got, this is the basis for our trigonometry subroutine. So we have managed to do all of question 15 here, task 15 here in Python, using subroutines and using a whole load of different mathematical functions within the math module and the C math module. I hope you've enjoyed this video. If you have, please hit that like button on the video, subscribe to my channel, and share this channel far and wide. And I look forward to seeing you on the next video. Thank you very much, and goodbye for now.